we're adding and subtracting, which means we have to have the same name. And for our fractions, of course, that means common denominator. So we're going to rewrite these with common denominators. For 6 and 8, we need to find the common denominator, which is going to be...
2.
Oops, you're thinking wrong direction. You're thinking common
Oh,
factor.
oh, I bet.
Common multiple, so it's going to be 24. So 6 times 4 makes 24. So I have to do 5 times 4 gets 20. 20 24ths is equivalent to 5 6. 8 times 3 gets 24, so 3 times 3 is 9. So it's 9 24ths is equivalent to the 3 8ths. So now that fraction is just the last digit at the end of the number. So we're going to go ahead and combine the fractions and then work our way back to the left. So 20 24ths and 9 24ths is 29 24ths. But of course, that's bigger than 1. So we can reduce that. We can take out 1, and there's 5 24ths left. So we'll keep the 5 24ths, and we'll carry the 1. 1 and 6 is 7, plus 2 is 9. So 9 and 5 24ths. For the second one, we are subtracting, and once again, we will need common denominator. So we're going to rewrite these. We got fourths and fifths. Our common denominator there is going to be 20ths. 4 times 5 makes 20. So 1 times 5 is 5. 8 and 5 20ths. To turn a 5 into 20, it's times 4. So 3 times 4 is 12. Now again, that fraction is just the last digit at the end of the number, so we're going to go ahead and subtract. We're going to do 5 minus 12 can't be done, so we're going to borrow from the 8. The 8 becomes 7, and now remember, what we borrow is one whole object, but our denominator tells us that whole object is 20 pieces. 5 plus 20 gives us 25 20ths. And now we can subtract. 25 minus 12 is 13 20ths. Keep the same name. And 7 minus 4 is 3. So 3 and 13 20ths. When we multiply and divide, we do not need the same name, so we do not need a common denominator. We saw yesterday that if we multiply mixed numbers, it's kind of a long process, a difficult process. So in order to avoid all that, we turn them into improper fractions. So 2 and 1/3, 2 times 3 is 6, plus 1 is 7, so it's 7/3. 3 and 3/5, 3 times 5 is 15, plus 3 is 18/5. Now, just like any other fraction multiplication, we can cross-cancel here. 3 and 18 can both divide by 3. 3 divided by 3 is 1, and 18 divided by 3 is 6. And now we just multiply straight across. 6 times 7 is 42, and 1 times 5 is 5. Now, 42/5 has to be reduced into a mixed number. 42 divided by 5. Well, 5 goes into 42 8 times. 8 times 5 is 40. We subtract, there's 2 left over. So remember, this is the whole number, that's 8, and then this is the numerator of our new fraction, 2, and the denominator stays fifths. 8 and 2/5. For number 4, division. Remember, division follows the same rules as multiplication. We do not need the same name, so we don't need a common denominator. We're going to combine counts and then also combine names. But again, with mixed numbers, it gets kind of ugly. So we're going to turn them into improper fractions again. So 4 and 1/5, 4 times 5 is 20, plus 1 is 21/5. 1 and 1/2, 1 times 2 is 2, plus 1 is 3/2. Now this is still division at this point. Turn it into multiplication. Remember, the division operates on the number that comes after it. So the 21/5 doesn't change. Dividing by 3/2 becomes multiplying by 2/3. Once again, we can cross cancel. We have 21 and 3, which both divide by 3. 3 divided by 3 is 1, and 21 divided by 3 is 7. And we can go ahead and multiply. 7 times 2 is 14. 5 times 1 is 5. To reduce that back down, 5 goes into 14 twice. 2 times 5 is 10. There's 4 left over. That is 2 and 4/5. Any questions there?
No, I don't think so.
Okay, so there is a quiz in Blackboard posted for you. That will be due by the end of class tomorrow. The class February 3rd. So make sure you get that downloaded and completed and then submitted. Today we're moving on to the next step after fractions, which is decimals. The key to understanding decimals comes back to that concept that we talked about with whole numbers of place value. So remember, if we started that decimal point and we worked our way back to the left, this is the ones, the tens, the hundreds, the 1,000s, the 10,000s, 100,000s, and it kept going as we went to the left. Well, now we want to go to the right. The decimal point would be at the end of the number there, so we normally wouldn't write it. But if we keep going, we would put in the decimal point, and then we have place values on this side. We notice a pattern with our place values. Whenever we move one place value to the right, the value of it, the place value of it, is divided by 10. 10,000 divided by 10 is 1,000. 1,000 divided by 10 is 100. 100 divided by 10 is 10. 10 divided by 10 is 1. And this pattern keeps going as we keep going to the right. 1 divided by 10 is 1/10. 1/10 divided by 10 is 1/100th. 1/100th divided by 10 is 1/1000th. 1/10,000. 100,000. And of course 1/1,000,000th. Now you might be looking at those place values on the right side there after the decimal point, and you might be thinking that those look suspiciously like fractions. And that's because that's exactly what they are. They're a shortcut way of writing certain fractions as specific denominators. In this case, denominators that are powers of 10. If I have 0.84, that's just a short way of writing the fraction 84 hundredths. Now, first thing, I want to review just a little bit how to pronounce a decimal. I know you've all done it. But you read the number, 84, and then it's the place value of the last digit. Hundredths is its name. Well, that's exactly how we put it into a fraction. It's that 84, and then the name of 100ths becomes our denominator. Now, of course, we wouldn't leave it like that. We could reduce that. Both 184 would divide by 4. 84 divided by 4 is 21. And 100 divided by 4 is 25. So 21/25. We might have 0.0375. So that is 375. The place value of that last digit is 10,000. Now, a little way to double check this is the number of decimal places. We have 1, 2, 3, 4. Better be the number of zeros in our denominator, and it does match up. Now, once again, we're not going to leave this as 375 over 10,000. Both of those can be reduced. Both can be divided by 25. 375 divided by 25 is 15. 10,000 divided by 25 is 400. We see that both of them can still be divided by 5. 15 divided by 5 is 3. 400 divided by 5 is 80. 3/80ths is the equivalent fraction for 0.0375. Now, we won't always have those place values there to help us out. Let's do 7.265. For this one here, first now we've got something in front of the decimal point. The first time we've had that. Well, just like fractions can be mixed numbers, where we mix whole numbers with the fractions, decimals can be mixed numbers as well. So that 7 is just the whole number portion of that number. 265 thousandths is what the decimal is saying. Again, 1, 2, 3 decimal places, 1, 2, 3 zeros in our denominator. And that can be reduced. Both 265 and 1,000 can be divided by 5. 265 divided by 5 is 53. 1,000 divided by 5 is 200. And I don't believe that can be reduced any further. Notice I left space there. That's because we need to remember our 7. That is 7 and 53 200ths. So our decimals are just, like I said, a shortcut way of expressing those specific fractions with those denominators that are powers of tens. Tens, hundreds, thousands, 10,000s, so on. So when we go to work with our decimals, the rules are exactly the same as any other number. When we add or subtract, must have the same name. So for our decimals, that means line up the decimal point. Now make sure that the place values, the individual place values that are the same, are lined up with each other. Then, of course, this part's probably a broken record. You combine counts, and you keep the same name. As we've seen, keeping the same name means to drop the decimal point straight down. So let's take a peek. Something like point. Now let's do this. 4.2 plus 3.87. When we go to 3.87, there we go. So when we go to add this, we have to be careful how we set it up. So we'll write our first number, 4.2. When I write the second number, the first thing I put in is the decimal point, because I know it has to go directly below the decimal point of that first number. Then I write the rest of the number around it, so 3.87. So this is addition. Now we should put in any missing decimal places. There's a spot there, so we should put a 0 in there to fill that in so that everything lines up. Now we can go ahead and add. 0 plus 7 is 7. 2 plus 8 is 10. Now, just like with whole numbers, we keep part of it, we carry part of it. So we keep the 0, we carry the 1. Notice that decimal point did not affect our carrying at all. The only thing the decimal point affects in our whole calculation is before we can cross the decimal point, we have to bring it down and put it in our answer. Now, 1 and 4 is 5, and 3 is 8. I'm going to spend a lot of time dwelling on addition. Let's jump to subtraction. We have something like 15.62 minus 8.95. Well, let's do 8.953. Let's do that. So when we go ahead and we write this again, 15.62. Again, I put the decimal point in the second number first just to make sure it stays lined up. Then I fill in the rest of the number around it. Once again, we should fill in any missing place values with zeros after the decimal. So that becomes 0.620, so we have 3 decimal places in both numbers. And now we'll go ahead and subtract. Now 0 minus 3 can't be done. I'm going to borrow from the 2, that's a 1, and this is now a 10. 10 minus 3 is 7. Well, 1 minus 5 can't be done, so I'm going to borrow from the 6. This will be a 5, this will be 11. Now it's 11 minus 5, which is 6. 5 minus 9 can't be done, so I borrow from the 5, that's a 4. This is a 15. 15 minus 9 is 6. Notice the decimal point did not affect our borrowing in any way. The only thing it affects is now that we're at the decimal point, before we can cross it, we have to bring it straight down. 4 minus 8 can't be done, so we borrow, that's 0, this is 14. 14 minus 8 is 6. So that is 6.667. I do want to show you one more subtraction problem, just because problems like this come up often enough, and they're a little bit tricky to do. Something like 8 minus 2.3764. First, we start off with the 8. Now, there's no decimal point there, which means it's at the end of the number, right there. So when I put in the second number, I'm going to start with the decimal point, and then I'll put the rest of the number around it to make sure things stay lined up. And we are subtracting. Once again, we need to fill in those missing decimal places. There's 4 zeros we're going to have to fill in up top. And now we go ahead and subtract. 0 minus 4 cannot be done, so we're going to have to borrow. Problem is there's nothing here to borrow from. It's a 0. So we have to keep going. We're going to go all the way over to the 8 to find something to borrow from. So that 8 becomes a 7. Well, that makes this 0 a 10. Well, that's great. We got it there, but we need to get it all the way down here yet. So we're going to have to keep borrowing. We have to do it over and over. So borrow from this 10, it becomes a 9. This 0 becomes a 10. Borrow again. Borrow from that 10, it's a 9. That 0 is a 10. Well, we still need to get one more place with it, so we borrow again. That's a 9. That's a 10 now. Now we have made it to where we started, where we needed our borrowing in the beginning, and we can go ahead and subtract. 10 minus 4 is 6. 9 minus 6 is 3. 9 minus 7 is 2. 9 minus 3 is 7. We're crossing the decimal point, so we're going to bring it down. Sorry, that's 9 minus 3 is not 7. 9 minus 3 is 6. Sorry. 7 minus 2 is 5. So 5.6237. So the key, make sure you put the decimal point in at the end of the number and fill in those missing zeros. Many of us were taught a shortcut that when you borrow like that, you just borrow here, then you fill in 9, 9, 9, 10. Well, that gets us to the same result, but you're skipping the steps. You're actually borrowing several times, repeating it over and over to get the amount down here to that last digit where we need it. When we multiply 4.28 times 3.6. We do not need the same name, which means we don't worry about lining up the decimal point. So 4.28 times 3.6. Notice I didn't line up the decimal point, and I don't care. We don't have to. So now we're going to start last digit of the bottom number, which is the 6, and we're going to combine that with the digits of the other number, starting with the last digit, so the 8. So 6 times 8 is 48, so that's 8, carry the 4. 6 times 2 is 12, plus the 4 is 16, so 6, carry the 1. 6 times 4 is 24, plus 1 is 25, so 5, carry the 2. Notice we completely ignored the decimals as we did that, and we're going to continue to ignore them. We're now going to move over to this next digit here. We're going to put a 0 in bottom or leave a space there. And I'm going to put a line up above so I know that anything below that line is old carries. 3 times 8 is 24, so this is 4. Carry the 2. 3 times 2 is 6, plus 2 is 8. 3 times 4 is 12. There's nothing carried, so it's just 2. Carry the 1. And now we can add our digits. 8 and 0 is 8. 6 and 4 is 10, so that's 0. Carry the 1. 1 and 5 is 6, plus 8 is 14. So we keep the 4 and carry the 1. 1 and 2 is 3, plus 2 is 5. And 1. To locate the decimal point, we've always been taught you count the number of decimal places in the original problem. There's 1, 2, 3 total decimal places in that original problem. So when you start at the end of your solution, you count backwards. 1, 2, 3 decimal places in your solution. The decimal point has to go there, 15.408. Well, there's a couple of other ways to think about that. This is hundredths. This is tenths. Hundredths times tenths better produce a thousandths digit. And that's what it did. Counting those decimal places and putting that many decimal places in the answer is just a way to combine those names. Now, there's an easier way to think about it even. This is about 4. This is also about 4. 4 times 4 is 16. So we're expecting a solution here close to 16. 1.5408 would not have made sense. 154.08 would not have made sense. Neither of those solutions would make sense with our answer. So the only place that it makes sense to put the decimal point is where we did there. Oh, that's not going to let you do it. Never mind. Division. Now, I'm going to warn you again. I'm going to do a little bit of a strange process of division here to begin with. You don't have to write it down. I'm just going to show you how that process of division that we saw on the second day of class applies to our decimals. I have, let's do 42.63 divided by 3.1. I look here, my first place value is the tens. I do 10 times 3.1, that's 31. Can I subtract that? Well, yes, I can. And I can subtract it only once. Subtracting 31 there. That gives me 9 left over. Well, that was a bundle of 10, and I did it one time. 10 times 1 is 10. Now I bring down the next digit, the 6. I bring down my decimal point. Next place value would be 1s. 1 times 3.1 is 3.1. I can actually take that out of there 3 times. 3.1 times 3 is 9.3. I would subtract, I'd have 3 there. So that was 1's place, bundle of 1s, times 3 of them. I just subtracted the 3.1 3 more times. Well, I still have this 3 to bring down. And now I've moved on to the 10th place. 0.1, the decimal point here, of course, is still there. 0.1 times 3.1 is 0.31. I can subtract that from what's here once, leaving me 0.02. So that was 0.1 times 1 is 0.1. I can keep adding zeros if I want to. As long as I'm after the decimal point, I can add zeros at the end of the number. I can bring down that 0. Well, even if I go to the 100th here, 0.01 times 3.1, 0.031, that does not go in there. I can go to the 1,000th, 0.001 times 3.1 is 0.0031. That will go in there 6 times. So that's 0.0186. Got to put an extra 0 in there. I subtract, I get 0.0014 left over. So that was the thousandths times 6. That's 0.006. Now I'm going to stop there right now. If I combine these digits, I have 13.106 is my result. That's the exact process we saw on day 2. Now remember, the process we were taught is a massive shortcut. This process has been whittled down tremendously so that we don't see most of the steps anymore. What we were taught to do for 42.63 divided by 3.1, first of all, we were taught not to divide by a decimal. We're not going to do that. What we're going to do, we move the decimal point over a spot to get rid of it. We'll move it over here as well. So it's now 426.3 divided by 31. Why are we able to do that? Well, we've said a few times that division and fractions are kind of interchangeable. I could make this 42.63 over 3.1 into a fraction like that. If I want to multiply the denominator by 10 to get 31, I have to multiply the numerator by 10 to get 426.3. That's exactly what we did here then, turned it back into a division problem. So moving that decimal point is completely valid. We're using our rules of fractions to do it. Now let's say I want this result to the nearest thousand. So let's look at how we're going to do that. The nearest thousand. 31 does not go into 4, so we leave that blank. 31 goes into 42 once. That's 31. We subtract, we've got 9. Bring down the 6. 31 goes into 96 3 times. 3 times 31 is 93. We subtract, we've got 3. Now, before I can bring down the next digit, I'm crossing the decimal point. So I'm going to bring the decimal point up. Now I can bring down the 3. See, over here, because there's place values in these, we didn't have to worry about the decimal point. It worked itself out. Anyway, we have to keep track. To keep it short, we have to keep track of the decimal point over here. 31 goes into 33 once. 1 times 31 is 31. We subtract, we've got 2 left. Now again, after the decimal point, at the end of the number, we can add zeros and it will not change the value. So I'm going to add a 0 here and bring it down. Now here, 31 does not go into 20, so I have to put a 0 up here above that 0 to account for that place value in my answer. Again, over here, it just all worked itself out. Add another 0 and bring it down. That's 200. Well, 31 does go into 200 6 times. 6 times 31 is 186. We subtract there, and we will have 14 left over. Well, we said we wanted to the nearest thousandths. That is the thousandths place. Can we stop there? And the answer is no. You got to add one more 0 and bring it down. That'll be 140. 31 goes into 140 4 times. 4 times 31 is 124. So there's 16 left over. The reason we had to go one more digit is when we say to the nearest thousand, we are rounding to the nearest thousandths. which implies that we have to know the next digit so we know whether we stay there or round up. This next digit being a 4 tells us that stays a 6. This is 13.106, the nearest thousand, which is what we had over here doing it the long way. This is the actual full process of dividing. Notice we don't have to move the decimal points or anything like that. In order to use our shortcut, we have to move the decimal points, get rid of the decimal points so we're not dividing by a decimal to make that shortcut work. So remember, there is that quiz on fractions that is out there. That is going to be due tomorrow, February 3rd. There will be another quiz tomorrow. I have it posted out there, so if you want to start early, you can. On decimals. That'll be due February 4th. And that'll be our 2 quizzes for this week. Our homework for today on decimals is page 63 through 65, 1 through 75, or 1 through 73 the odd, and page 72 through 75, 1 through 67 the odd. As always, I'm not expecting you to go home and do 70 problems tonight. Do some of the easy ones, skip ahead to the more difficult ones, make sure you feel comfortable with them. If there are word problems, make sure you try a few of those. I tend to take the word problems for my quizzes and tests directly out of, or very similar to, homework questions. So make sure you're familiar with all them. And with that, does anybody have any questions?
Nope.
Okay, so we have about 13 minutes left. I'll give you that time to start on your homework if you want. I will be on